All right. Hello, everyone. My name is Jim. Okay, thank you. I was about to ask about that one. This is my first talk, so I hope it goes over well and hope you all enjoy it. This is the anatomy of drug testing. The core of this talk is going to be mainly just going over what's tested for, why it's tested for, the specifics of the how the tests work as a sciences and stuff like that. Now, my slides, I don't put a lot of information on them. Honestly, they're just going to be more like notes for me to remember what I'm talking about. I want to start off more on the legal end just so you get an idea of some of the information. Scheduling is where drugs are set up at on a legal standpoint. Now, Schedule 1 is where you're going to find most of your drugs. Pot, heroin, methamphetamines, things of that nature. Schedule 1 drugs are technically supposed to be drugs that are highly addictive, no medical purposes. They are considered to be dangerous to society, things of that nature. It is not legal to own them without DEA approval. Now, Schedule 2 have a slight medical advantage, but are still highly addictive and dangerous. A weird example of this one would be cocaine is actually a Schedule 2 drug instead of Schedule 1. Reason being is cocaine is actually used still as an anesthetic in certain kinds of surgeries. I believe ocular surgeries, they'll still use it on occasion. Now, Schedules 3 and 4 is where you start getting into drugs that are less addictive, they have less social context of causing harm to people. They don't cause physical harm. They're not addictive, things of that nature. You're looking at a lot of, like, say, antipsychotics, antidepressant medicine for, like, Schedule 3. Schedule 4, your, acetaminophen, salicylates, painkillers of the lower end that you buy at the street, maybe Benadryl, things of that nature. Now, onto the actual legal stuff that matters more is the DOT. DOT is Department of Transportation. This is huge when it comes to drug testing because the DOT will mandatory drug test anyone who operates a commercial vehicle. And their rules are where the strictures are. DOT regulations state that the panel has to be at a minimum of a 5-point panel, usually THC, amphetamines, cocaines, opiates, and I believe it's going to be barbiturates, possibly. The fifth one can vary from time to time. And some of the rules behind how it has to be done, it has to be done completely illegally with a chain of custody form, the COC form. Everything has to be documented properly. The person has to go into a secure location in order to take the piss test. And with a secure location, water cannot be running. You are looking at everything that could potentially have a dispenser is going to be taped off so you're unable to use it. The toilet bowl would be blued out, so if you bring out the sample and you try to use the toilet water, it's not going to be valid because it'll be some kind of sickly green color. And then if the DOT person is coming in for a reason other than, say, a random pre-employment, say there's a reason of suspicion, there's an accident, or they're acting a little bit weird, DOT regulations also state that someone in those circumstances is going to have an observed collection. First person will have to empty out all their pockets, they'll have to pull their pants down, pull their shirt up, spin around the circle to make sure there is nothing present that could potentially be used as an alternate sample, and then go into the bathroom and still be observed of the urine leaving the person's body and going into the sample cup. Now, there's also non-DOT, which is just still a legally binding, but it's not as strict because you're not dealing with the driving on the roads. Non-DOT, you basically just sign your form, you walk in there, it's still a secured room, but then you walk back out and you sign in a couple of things. Usually you'll sign the actual container that the urine specimen will be sent into the testing research facility, and then you're on your way. Now, BATs, breath alcohol, same thing, chain of custody. They're not as detailed as the DOT ones. Now, these are the ones that the hospitals and the police can both use. They are also legally binding. Someone who says that the breath alcohol is not as specific or accurate as a hospital testing, the hospital that I work for actually uses the exact same breath alcohol machine for our BATs as the police departments in the region that I live in. And we have been able to test to make sure that our chemistry machines can test the actual BAC directly from the blood as opposed to the BAC from the breath, and they are right on comparable. Now, the methodology is here. These methodologies are 5 of the primary ones you're going to end up seeing and they're going to be getting used for your drug testing. EIA and ELISA is one of your most basic. What this is if you want to think about it this way, think of like a pregnancy test. You piss in the strip and you'll see like a little bit of a water line moving up, and if there ends up a colored line forming, then you're pregnant. These work off that same principle. It's working with antibodies and enzymes and things of that nature. What's going to end up happening is where that little line is, there's a strip of antibodies attached to the filter. And when the drug, let's just say THC, passes over that line, the THC will bind to those antibodies. Now, there's also antibodies that are at the very base where you actually put the sample on that are filtered out, and those antibodies will bind to a different part of the THC molecule. So what you end up doing is you end up getting this antibody right here, and then you have your THC, this is on the actual cassette, and then the molecule holds on the right here. And then another antibody will grab on the right here. The top of that antibody is made to be colored, so that if all these THC molecules end up attaching, then the colors, these secondary antibodies will attach to that one, creating almost like a sandwich of antibodies and these molecules, allowing there to be a defined line. Obviously, if there's a high level of THC or whatever drug you're testing for on there, the line will become very, very thick and dark, whereas there's a very small amount, it'll be a very faint line. It's only a qualitative test, though. I mean, it's not going to give you any kind of definitive number, like you're not going to have, 50 milligrams per deciliter of a sample on that one. For that one, you'll need the other 4. The next one is spectrophotometry. Spectrophotometry is used in actually not only drug testing, but is a major testing style of most, I won't say most, but of many of the different kinds of tests that the hospitals will be running. I mean, this thing will test your levels of potassium, it'll test your levels of different drugs, and also different enzymes and proteins that are found in your blood, urine, and other kind of body fluids. Now, the way the spectrophotometry works is you have, with where I work, we use what's called a dry slide. It's a newer kind of spectrophotometry. It's just now starting to become increased. And what happens is you take the slide and the machine will dispense, say, like 5 microliters of specimen. It'll dispense it onto this slide, and the slide will have filters in there to filter out what it doesn't want in there. And then what isn't filtered through would go down to the bottom, which has enzymes. And these enzymes are going to react with these different drugs, and with these reactions, it will change the color, kind of like, you add iron to oxygen, it goes from clear and gray to a reddish color from the rust. The machine will take this color, it'll see how much of a color change there is, how dark it gets, the differences and everything of that nature. And with these different changes in color, it'll actually give a very specific amount of a level of the drug that's in there. Good example that I see a lot is alcohol testing from people coming into an ER. Like a 0.1 that I would see would be equivalent to a 0.1% for that. With spectrophotometry, you're looking at a lot of times your alcohols. I believe there's some for cocaine, acetaminophen, salicylates, a lot of the ones that aren't really going to matter too much. The big one legally is going to be alcohol. That's going to test for. Now, chemiluminescence as a test. Chemiluminescence uses a similar concept as the EIA and the ELISA. What chemiluminescence does is it has a base of these antibodies, and then the chemicals, the drugs that we're testing for, will attach to these antibodies, and they're going to be inside a tiny little cuvette. They get incubated for a while, warmed up to the correct temperature, and then through a series of acids and bases that are being splashed in through there, it shoots out a bit of light at the cuvette after being washed out these acids and bases. And the molecules that are attached to the other end, instead of being color, are photoreactive. And the machine will measure how much of of this flash of light that is shot at it. It will absorb it and then release that light back out. It'll find out how much of that light is absorbed and then released back out. And it will actually give a very quantitative result and definitive answer as to how much the person has in their system at that time. Now, GCMS, actually, I'm going to go in a different order. I'll go with the breathalyzer first. GCMS is a lot more advanced. The breathalyzer, simply the way that one works is when you breathe in, show of hand, who here has actually had to take a breathalyzer for whatever reason? Wow, I'm impressed. You people are either very good or just not doing it right. The way the breathalyzer work is, I mean, for everyone who raised their hand, they'll know the officer in question is always saying, all right, now breathe deep, keep breathing, keep breathing, keep breathing. They don't let you stop giving one breath until the machine goes off. The reason being is that the breathalyzer is specifically meant to wait till the breath is becoming exhausted to start measuring the sample. What that's doing is that's going to get a deep, long sample instead of one that's upper more toward the surface where it's going to be saturated with alcohol. And that's the other reason why they make you wait, say, 15 minutes, 20 minutes before you give a sample, because so much as eating a sandwich, having a breath mint can actually throw off the results of the test. Sadly, it'll only give false positives. It really won't get any kind of false negatives. But your body is releasing the alcohol through the bloodstream into your lungs, and that's what they're testing on for that one. Now, GCMS, gas chromatography mass spectrophotometry. For anyone here who's watched CSI, which is sadly probably most of us, if you remember seeing where they're like, all right, this person has this drug in it, and they look at this little strip of paper and it has like these tiny little juts of like spikes and peaks and things of that nature, that's GCMS. What GCMS does is actually two different tests that they use in conjunction because neither one is specific enough to give a definitive result by itself, but when used together, they can piece the information with each other to give a result that is incredibly specific and incredibly accurate. What happens with the gas chromatography is they take a tiny sample and they heat it up to make a gaseous form out of it. And then with this gaseous form, they take a stream of air, usually of an inert gas like radion or something along those lines, and shoot it through a coil. Now, inside this coil are chemicals that are made to be able to attach to certain enzymes or certain chemicals and not to other ones. So these molecules that have been suspended into a gaseous form start shooting through this line. Now, dependent upon how reactive how reactive the chemicals are to the inner lining of this tube, and depending upon the size, the different chemicals will come out at the end of the coil at different times, and a gas chromatographer will actually end up creating a list of, okay, it's possibly this one is at this time, this one's at this time, this one's at this time, so these molecules could potentially be this. Now, say like cocaine could have a similar time to pop out as THC. That's the reason why it's unaffected by itself. Now, mass spectrophotometry requires a very, very pure sample. It requires also, the way it works